In lesson 7.5, we are going to be talking about using proportional relationships. And basically, we're going to look at solving some real-world problems with this. Indirect measurement is any method that uses formulas, similar figures, and or proportions to measure an object. So basically, when you're talking about using indirect measurement, you are not directly measuring with a ruler or a yardstick or a tape measure, but you're using other methods. If we take a look at example A, it says that Tyler wants to find the height of a telephone pole. He measured the pole's shadow and his own shadow and then made a diagram. What is the height of the pole? So we know that Tyler wouldn't be able to directly go measure the telephone pole. He's not tall enough. He's using indirect measurement. And you see a lot of problems that use the shadow of an object to do this. Well, if you can imagine your sun up here, when your sun shines down, the rays are parallel. So your object to the ground, we assume 90-degree angle, and because of the rays of the sun, we actually have a congruent angle formed there as well. So my triangles are similar by angle, which allows me to set up a proportion to solve. Now the other important thing in this question is that if Tyler's 5 feet 9 inches, his shadow's 7 feet 8 inches, and so on, I can't say that 5 feet 9 inches, I can't say that's 5.9. So I need to do some converting. I either need to convert that into total feet or to total inches. Now, 5 feet 9 inches is 9 inches out of 12, right? So 5 feet 9 inches would be 5 and 9/12 feet. And then we would reduce that to 5 3/4. And we could convert all of them to total feet. Now, what I typically find, though, is that students would rather convert it to inches. If I were converting this to inches, I would take 5 times 12, and then I would add in the extra 9. So 5 times 12 is 60, and then I have another 9 inches. This would be 69 total inches, or 5 3/4 total feet. And you could use either number, but you need to be consistent. So if you choose to convert to inches, we need to convert all of our measures to inches. So 7 feet 8 inches, well, that's 7 8/12 of a foot, or it would be 92 inches. 38 feet 4 inches, well, 38 4/12 of a foot, which would be a total of 460 inches. Now, keeping in mind when we solve for our height of h, then our total height is going to come out in inches. So I'm going to go ahead and I'm going to set up my proportion. I know that the height of Tyler is going to correspond to the height of the pole. So I'm going to say, well, 69 inches over h would be equal to, the shadow for Tyler is 92 over 460. And now I can just go ahead and use our cross products. We are going to find that 31,740 is equal to 92h, and we divide and we find out that h is 345 total inches. Now, typically, I'm going to ask you to give your answer in feet and inches, so I don't necessarily want it 345 inches. We would go ahead and divide by 12. Now, if you divide by 12, we're going to find that this is 28.75. Again, I want my answer in feet and inches because that's how they were in the problem. So that tells me that I know that we have 28 feet, and my inches would really be my remainder. What would be left over? Or you may know that 0.75 is 3/4, and 3/4 of a foot is 9 inches. Today we're also going to work with some scale factors. And down below it says that a scale drawing represents an object as smaller than or larger than its actual size. The drawing scale is the ratio of any length in the drawing to the corresponding actual length. Now I know that you have made or worked with problems with a given scale before. You may even have done a scale drawing in some of your art classes, and you know that because of the scale, you're able to keep things in proportion so it's not distorted. Over here, there's a reminder that it says a proportion may compare measurements that have different units. And so you don't necessarily have to work with all centimeters or all meters when you work with your proportion. Let's take a look at example B, and I'll show you. Example B says that on a Wisconsin road map, Kristen measured a distance of 11 1/8 inch from Madison to Wausau. The scale of this map is 1 inch to 13 miles. What is the actual distance to the nearest mile? Well, here is my scale, that's going to give me the first part of my proportion. Now, my scale does have units, 1 inch to 13 miles. I can use that to set up a proportion as long as I know that on this side, I'm also going to have inches to mile. Now, what I'm given is on the map, it's 11 1/8 inch. So I know that that is going to go on the top. When I'm really looking for x, how many miles? We would solve our cross products, or here I can actually see that, you know what, this is just 1 inch as 13 miles. I know I'm just going to go ahead and multiply those. Now, when I multiply them, I end up getting 144.625. 144.625, well, that's 144 3/8. But this does ask to the nearest mile, or sorry, 5/8. So the question is, how is that going to round? To the nearest mile, that's going to force that to round up to 145 miles. Now, if I had asked you to give that in miles and feet, a reminder that there's 5,280 feet in a mile, so we'd want to know what 5/8 of that would be. Or we could figure out how many left over, what would be the remainder. It ends up being 144 miles and 3,300 feet. Let's look at another one. Lady Liberty holds a tablet in her left hand. The tablet is 7.19 meters long and 4.14 meters wide. If you made a scale drawing using the scale 1 centimeter to 0.75 meters, what are the dimensions to the nearest tenth? So in this case, my scale, 1 centimeter to 0.75 meters, I'm looking for the dimensions. I'm actually looking for the length and the width of your drawing. And as before, we said we know we'd have to have centimeters and meters. Well, sometimes kids get confused because they have two different numbers to work with. I'm actually going to need to solve two proportions, one to find my length, one to find my width. So the first time, if I'm going to go ahead and take my 7.19 meters, that's the actual, I'm looking for L, my length, and we could solve our proportion. We could use our cross products, multiply, divide by 0.75, but then I'm also going to have to take that same scale, and I'm going to have to set that up and solve for the width. And so I'm looking for the width of the drawing when I know the actual is 4.14 meters. And again, we would use our cross products. Now it asks me to round to the nearest tenth, and so here we would find that my length is going to be approximately 9.6 centimeters, and my width would be approximately 5.5 centimeters. a look, I have a little investigation at the top of our paper. We are given two triangles that are similar. And if we compare them, we can see that we could come up with our ratio. The similarity ratio, small to big, well, 3 to 6, 5 to 10, 4 to 8, we can see that ratio would be 1 to 2. If I were looking for the ratio of the perimeters, well, the perimeters, when we add up the outside, here, 3 plus 4 plus 5, I'm going to see it says perimeter of 12. 6 plus 8 plus 10, that's a perimeter of 24. Well, 12 to 24 also gives me a 1 to 2 ratio. So when my triangle, essentially the side lengths are doubled, the perimeter is also doubled. But what about if we look at the area? Area of a triangle is 1/2 base times height. 1/2, 3 times 4. Well, that would have an area of 6 square units. And this triangle, 6 times 8 times 1/2, that would also have an area of 24. Well, a ratio of 6 to 24, that actually is a comparison 1 to 4. Well, what happens is a lot of times kids think just because we double the side lengths that my area is going to double. But you can see here that my area actually multiplies by 4. So my area quadruples. The proportional perimeters and areas theorem reads as so. If your similarity ratio of two figures is A to B, the perimeters will have a ratio of A to B. So that's going to be the same as your similarity ratio. But the areas will have a ratio of A to B squared, which would also be written as A squared over B squared, which we saw up above, because if we take 1/2 and we square it, we're going to end up with 1/4. Well, we can use that to sometimes set up and solve for perimeter and area. Instead of actually calculating them out, we can use some proportions. So when I look at example C, I see that my triangles, they're telling me they are similar. My triangles are similar, and I'm looking for the perimeter and the area of the smaller triangle. I don't have enough information to calculate it as far as my base and my height go, but I can use the fact that this larger triangle is similar, and I do know the perimeter and area of that one. So when I look at my triangles, I see that corresponding side, 13 and 9.1, that actually gives me my ratio, 13 to 9.1. We could leave that as that fraction if we wanted to work in our proportion, but if you go ahead and simplify, you'll find out that that's a 10 to 7 ratio. Well, what does that mean? If I'm looking for my perimeter, my perimeters are also going to have a ratio of 10 to 7. And so if my larger triangle has a perimeter of 36 centimeters, I can go ahead and calculate for x my smaller perimeter. Cross multiply and divide, and you would find out that this perimeter would come out to 25.2 centimeters. And of course, we always want to make sure that that seems logical or makes sense. What about my areas? Well, my areas do not have a ratio of 10 to 7. Rather, they have a ratio of 10 to 7 squared. So when I set up this proportion, I'm going to say 100 over 49. 100 over 49, that would be equal to 60 over y. Here, y being my area, I'm going to cross multiply and divide. And we find out that that area would come out as 29.4 centimeters squared. that A for area. So even though I didn't have enough information to calculate it with the formulas, I could set up what a proportion to solve. Finally, it says that the ratio of the areas of two similar figures is 4 to 9. What is the ratio of the corresponding side lengths? Okay, my areas have a ratio of 4 to 9. I'm just going to make that known. I'm wondering about the similarity ratio. Well, is it going to be exactly 4 to 9? No, this is actually what we would get if we take A over B and we square it. So to get our similarity ratio, we actually need to undo that. Well, would you agree that we need to take the square root of A over B squared? And so if I take the square root of 4/9, I'm thinking about the square root of 4 over the square root of 9. And we would find that our similarity ratio then would be 2 to 3. Okay, if you have further questions on this, please stop in and see me.